Hi, I'm Aneri Dunn, and I'm a master's in data science student at the University of San Francisco. Today, I'll be walking you through my project on predicting hotel booking cancellations using machine learning methods. Now, hotels receive several reservations throughout the year, and several of these reservations get cancelled. These cancellations represent a loss in revenue for the hotel management. If there was some way through which the management could predict hotel booking cancellations, either through using customers' current information, the booking unit's current information or prior information, then that unit could be released and be made available to be booked again, thereby allowing the management to compensate for the lost revenue. It can also help in guiding management decisions regarding cancellation policies. To address this problem, I used a dataset available from Kaggle.com. It was a fairly large dataset with around 119,000 rows and 31 columns excluding the target variable. The target variable is cancelled was a binary variable wherein 0 represented that the booking was not cancelled and 1 represented that the booking was cancelled. The distribution of the target variable, as can be seen from the graph on the right, was a bit imbalanced, wherein the number of cancellations were far lesser than the number of non cancellations. The next step was to conduct an exploratory data analysis in order to find out the nature of the input data and engineer better features. Key findings from EDA were that the column's reservation status and the reservation status date were updated after the booking had been cancelled. Including these in the model would have resulted in data leakage. Another key insight was that the columns company and agent had a lot of missing values. And within the values that were already there, the number of distinct categories were far too much to use imputation. Therefore, the solution was to drop these columns, and this was handled by pipeline. This is a binary classification problem, and I trained two models on the data in order to compare their performance. These models were random forest and logistic regression. Let me walk you through my code so that I can explain it to you better. The first step was to split the data into train and test data sets. I used a test size of 25% in order with a random seed in order to ensure the reproducibility of my results. The categorical and the continuous variables were meant to be treated differently, and which is why they had their own pipelines. These pipelines were later aggregated using a column transformer. The first model that I fit was random forest. I wanted to explore how the creation of an ensemble impacts this data set, which is why I experimented with the number of estimators, max depth, minimum samples per leaf, and the way max features were decided to be fed into each of these trees. I also wanted to check whether bootstrapping had any impact on the model's predictability. The metrics used for scoring each of these models were a balanced accuracy score. This was my primary metric because it captured the recall of each class in a single metric and accounted for the imbalance in the dataset. I also wanted to look at precision and recall individually as well as the F1 score in order to capture both using a single metric. Using randomized search CV and the hyperparameter space, I fit the model onto the training data. The best parameter resulted in an ensemble with 20 estimators, 10 samples per leaf, and a max depth of 15. Also, the best balanced accuracy score that came out from this model was around 79%. This meant that the model, on an average, could correctly identify 79% of the labels from each class correctly. The next model that I trained was logistic regression. Following the steps similar to a random forest, I wanted to explore the impact of the strength of the regularization on this data set, which is why I experimented with different values of C. Again, using randomized search CV, I fit the model on the training data and obtained the best parameters. A value of C of 1000 indicated that regularization did not have too much impact on the data set. and resulted in a balance accuracy score of 80%. Because the balance accuracy score of logistic regression was higher than that of random forest, I decided to go with logistic regression as my final model. I trained the entire data I trained the entire data using the logistic regression model and got the predictions for the test data set. Using these predictions, I obtained the metrics for the final model. The metrics of a balanced accuracy score, precision, recall, and F1 score were all in the range of 80 to 81%, which indicated that the model did a fairly good job in predicting whether a hotel booking was likely to get cancelled. I feel this model is just a starting point and can guide the management in making a decision whether, if a hotel booking is likely to get cancelled, they can allocate it to some other customer and compensate for the lost revenue. Because it has a balance accuracy score of 81%, it works the other way around too. It means that um, it would reduce the chances of an event that the customer shows up only to find out that the booking has been allocated to someone else, resulting in reputation and revenue loss for the management. While this represents just a starting point, the model's predictive ability could be made better by engineering more features and including exogenous data like real-time weather data. Um, if we could also predict the number of days within which a hotel booking would get cancelled, if in the instances in which it was cancelled, it could help the management to update their cancellation charges dynamically and update their cancellation policies accordingly. Thank you.